Now, in this lecture, we will find out the value of angle x using two different methods. In the drawing, we have triangle PQR. We know that QS is equal to SR, and we also know that angle PSQ equals to 45 degrees. And we know that angle PQS equals to 3x and angle PRS is equal to x. And we want to find out the value of angle x. So we will start with the first method, and we will define angle QPS as alpha. And we will also define angle SPR as beta. And what is the size of angle PSR? We will define angle PSR as y. We know that QR is a straight line. Here, QR is a straight line, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. That is to say, if you focus on the upper side of the straight line QR at point S, then on the upper side at point S, the sum of the angles must be equal to 180 degrees. That is to say, 45 degrees plus y must be equal to 180 degrees. So I'll write it down. So 45 degrees plus the size of angle y must be equal to 180 degrees according to the rule that I mentioned. Here we will subtract 45 degrees from this equation, and we will get that angle y equals to 180 degrees minus 45 degrees. That is to say, angle y equals to 135 degrees. So we found out that angle y equals to 135 degrees. So we can substitute y by 135 degrees. In the next step, I will present to you a new rule. It is actually the law of sines. So what is the law of sines? The law of sines The law of sines is true for any triangle, so write that in any triangle so if we have a triangle and we know that the length of this side is equal to A units, and the length of this side of the triangle is equal to B units, and the length of this side of the triangle is equal to C units, and we also know that the opposite angle of this side is A, and the opposite angle of this side is B, and the opposite angle of this side is C. Then, according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. Okay, I'll repeat again. A is the length of this side, B is the length of this side, and C is the length of this side. So according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. Here we can derive from this formula that A over sine A equals to B over sine B okay, and we will multiply this formula by sine A, and then we will divide it by B, and we will get that A over B equals to sine A over sine B. So what does this formula mean? The meaning of this formula is that the ratio between the side lengths of any triangle is equal to the ratio between the opposite angles. Okay? I write it down. The ratio between the side lengths in any triangle is equal to the ratio between the opposite angles. Okay, I'll repeat again. The ratio between the side lengths in any triangle is equal to the ratio between the opposite sides, between the opposite angles. Okay, A over B equals to sine A over sine B. We will return to our drawing, our original drawing. In our original drawing, we can write down that PS over QS, PS over QS is equal to PS over QR. Or PS over SR. Or PS over SR. Why this equation is true because of the fact that QS is equal to SR according to what is given us in the question. So I'll repeat again, according to equation number 1, PS over SQ equals to PS over SR. It is true because QS is equal to SR. And we just right now found that the ratio between the triangles, the left sides of the ratio between the left sides of any triangle is equal to the ratio between the opposite angles. So if we focus on triangle PQS, it means that PS over QS equals to sine 3x over sine alpha. Sine 3x over sine alpha. And if we focus on triangle PSR, then PS over SR will be equal to sine X over sine beta. Okay? So we got the equation number 1 that states that sine 3x over sine alpha equals to sine x over sine beta. We know that the sum of the angles in any triangle is equal to 180 degrees. So if we focus on triangle PQS, we know that the sum of the angles of triangle PQS is equal to 180 degrees. That is to say, we will get that alpha plus 3x plus 45 degrees must be equal to 180 degrees. I will repeat again. In triangle PQS, the sum of the angles is equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees equals to 180 degrees. Here we will subtract from equation number 2 3x and also 45 degrees, and we will get that according to equation number 2, angle alpha equals to 180 degrees minus 3x plus 45 degrees. So we actually found out the value of alpha in terms of x. Likewise, in triangle PSR, the sum of the angles must be equal to 180 degrees. This triangle PSR, that is to say, beta plus x plus 135 degrees must be equal to 180 degrees. I will repeat again. In triangle PSR, the sum of the angles must be equal to 180 degrees. Here in triangle PSR, that is to say beta plus x plus 135 degrees equals to 180 degrees. We will subtract 135 degrees and also x from this equation number 3, and we will get that angle beta according to equation number 3, angle beta equals to 180 degrees minus 135 degrees is 45 degrees and minus x. So we found out that angle beta equals to 45 degrees minus x according to equation number 3. So after we found out alpha and beta in terms of x, we will substitute alpha and beta in this equation, equation number 1, by the values that we found in equation number 2 and equation number 3 for alpha and beta, and we will get that sinus 3x over sine alpha, and we found out that sine alpha according to equation number 2, that alpha equals to 180 degrees minus 3x plus 45 degrees, so I write it down. And it equals to sinus x over sinus beta, and beta equals to 45 degrees minus x according to equation number 3, so we substitute beta by 45 degrees minus x, and we actually have the trigonometric identity that states that sinus 180 degrees minus theta equals to theta, so according to this trigonometric identity, the value of sinus 130 degrees minus 3x plus 45 degrees will be equal to sinus 3x plus 45 degrees, so I write it down. Sinus 3x, and here sinus will be sinus 3x plus 45 degrees, and it equals to sinus x over sinus 45 degrees minus x, so according to question number 1, we got that sinus 3x over sinus 3x plus 45 degrees equals to sinus x over sinus 45 degrees minus x. Here we will cross multiply equation number 1, and we will get that sinus 3x times sinus 45 degrees minus x equals to sinus x times sinus 3x plus 45 degrees Here we will multiply equation number 1 by 2, and we will get that 2 sine 3x sine 45 degrees minus x equals to sine x times sine 3x plus 45 degrees. So here we will use the trigonometric identity that 2 sine A sine B equals to cosine A minus B minus cosine A plus B in order to simplify those expressions in equation number 1. So the trigonometric identity is 2 sine A times sine B equals to cosine A minus B times minus cosine A plus B. So according to this trigonometric identity, the value of 2 sine 3x sine 45 degrees minus x, first of all, we know that A equals to 3x and B equals to 45 degrees minus x. So 2 sine 3x sine 45 degrees minus x will be equal to, according to this trigonometric identity, to cosine A minus B. Cosine A minus B. A is 3x and B is 45 degrees minus x, so it is 3x minus minus x is 4x. And 0 minus 45 degrees is minus 45 degrees. So it is cosinus A minus B minus cosinus A plus B. Minus cosinus A plus B. A is 3x, B is 45 degrees minus x, so A plus B will be equal to 3x plus minus x is 3x minus x, that is 2x. And 0 plus 45 degrees is 45 degrees. Okay, so we finished with this side of equation number 1. We will go to the other side, and we found out the value of 2 sine x sine x plus 45 degrees. So 2 sine x sine 3x plus 45 degrees. First of all, we know that A equals to x and B equals to 3x plus 45 degrees. So we will get that it equals to cosine A minus B, so it is cosine A minus B. X minus 3x is minus 2x, and a minus b is x, so it is actually a minus b is x minus 3x and 0 minus 45 degrees. 0 minus 45 degrees is minus 45 degrees. So in conclusion, we found out that cosine a minus b, it is actually cosine minus 2x plus 45 degrees. But because of the fact that we have the trigonometric identity that states that cosine of minus x equals to cosine x, because of the fact that cosine minus x equals to cosine x, then we can change the sign of minus to plus. That is to say, cosine minus 2x plus 45 degrees equals to cosine plus 2x plus 45 degrees. Okay, so we change the sign of minus to plus, and it is actually equals to cosine 2x plus 45 degrees. And we have also minus cosine a plus b. So it is minus cosine a is x and b is 3x plus 45 degrees. So a plus b is x plus 3x is 4x. And 0 plus 45 degrees is 45 degrees. So here we have this equation. Actually, we have cosine 4x minus 45 degrees. I will copy it here. Cosine 4x minus 45 degrees. And we will add to this equation number 1, cosine 4x plus 45 degrees. So here we have plus cosine 4x plus 45 degrees. And it will be equal, we will add to this equation cosine 2x plus 45 degrees. So in the other side of the equation, we will get 2 times cosine 2x plus 45 degrees. Okay. So we have cosine 4x plus, minus 45 degrees plus cosine 4x plus 45 degrees. We will simplify this expression by the trigonometric identity that states that cosine C plus cosine D equals to 2 cosine C plus D over 2 times cosine C minus D over 2. Okay, and we also use another trigonometric identity for cosine 2x plus 45 degrees. We will use the trigonometric identity that cosine A plus B equals to cosine A cosine B minus sine A sine B. So the expression cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees. Here C equals to 4x minus 45 degrees and D equals to 4x plus 45 degrees. So according to this trigonometric identity, we will get that cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees will be equal to 2 cosine C plus D over 2. C is 4x minus 45 degrees and D is 4x plus 45 degrees. So C plus D, it is actually 4x plus 4x, that is 8x. 8x over 2 is 4x. And minus 45 degrees plus 45 degrees is 0. And it is actually also equals to cosine C minus D over 2. So it is cosine C minus D. C is 4x minus 45 degrees and D is 4x plus 45 degrees. So C minus D will be equal to 4x minus 4x is 0. And minus 45 degrees is minus 90 degrees, and the minus 90 degrees over 2 is minus 45 degrees. But because of the fact that cosinus minus x equals to cosinus x, we will get that cosine minus 45 degrees equals to cosine 45 degrees. Okay, so we finished with this expression. Now we will get to this expression, to the second expression, cosine 2x plus 45 degrees. Here A equals to 2x and B equals to 45 degrees. So cosine A plus B equals to cosine A cosine B. Cosine A is 2x, so cosine A is cosine 2x. Cosine B is 45 degrees, so it is cosine 45 degrees. Minus sine A sine B. It is actually sine 2x times sine 45 degrees. So in conclusion, we got this expression that 2 cosine 4x cosine 45 degrees equals to 2 cosine 2x cosine 45 degrees minus sine 2x sine 45 degrees. Here we will divide this equation by 2 cosine 45 degrees, and we know that sinus 45 degrees equals to cosine 45 degrees. So we will divide this equation by 2 cosine 45 degrees. So here 2 cosine 45 degrees will get cancelled, and here also 2 cosine 45 degrees will get cancelled, and here it is actually 2. Here it is 2. So here also 2 sine 45 degrees will get cancelled because of the fact that sine 45 degrees is equal to cosine 45 degrees. So what is left from equation number 1 after we cancelled 2 cosine 45 degrees? What is left? It is actually, here we have cosine 4x equals to cosine 2x minus sine 2x. Okay? We got that cosine, according to equation number 1, cosine 4x equals to cosine 2x minus sine 2x. Here we will add to this equation number 1, sine 2x, and we will add sine 2x and subtract cosine 4x, and we will get that sine 2x equals to cosine 2x minus cosine 4x we know that sine 2x equals to 2 sine x cosine x, so I'll write it down. We'll get that sine 2x equals to 2 sine x cosine x, and it equals to cosine 2x minus cosine 4x. So here we will use the trigonometric identity that states that cosine C minus cosine D it equals to 2 sine D plus C over 2 times sine D minus C over 2. So we will use this trigonometric identity in order to simplify the expression of cosine 2x minus cosine 4x. So here we get that in the other side of the equation number 1 we have 2 sine x cosine x, and it equals to cosine 2x minus cosine 4x. So here C equals to 2x, D equals to 4x, and cosine 2x minus cosine 4x according to this trigonometric identity will be equal to 2 sine D plus C over 2, 2 sine D plus C over 2. C is 2x, D is 4x. So D plus C is 2x plus 4x, that is 6x, and 6x over 2 is 3x, times sine D minus C over 2, D minus C. D is 4x, C is 2x, so 4x minus 2x is 2x, and 2x over 2 is x. Okay? So here we got equation number 1 that states that 2 sine x cosine x equals to 2 sine 3x sine x. Here we will divide equation number 1 by 2 sine x. So here 2 sine x will get cancelled, and here also 2 sine x will get cancelled. And what is left from equation number 1 after we cancel 2 sine x, what is left, it is actually, according to equation number 1, cosine x equals to sine 3x. That is what is left. Cosine x equals to sine 3x. We have the trigonometric identity that states that cosine alpha equals to sine 90 degrees minus alpha. I'll write it down. Cosine alpha equals to sine 90 degrees minus alpha. So according to this trigonometric identity, we will get that cosine x equals to sine 90 degrees minus x. and it equals to sine 3x. So sine 90 degrees minus x equals to sine 3x means that 90 degrees minus x equals to 3x. Here we will add to equation number 1 x, and we will get that 90 degrees equals to 3x plus x is 4x. Here we will divide equation number 1 by 4, and we will get that x equals to 90 degrees over 4, that is actually 22.5 degrees. So we found out that angle x equals to 22.5 degrees according to the first method. So we finished with the first method. In the next step, I will present to you how to find out the value of angle x according to the second method. In the second method, we will define angle QPS as alpha as we did it in method 1, and we will define angle SPR as beta, and we have already found out that this angle equals to 135 degrees. And we also know that the sum of the angles in any triangle is equal to 135 degrees. So in triangle PQS, the sum of the angles must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. I repeat again, in triangle PQS, the sum of the angles must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. Here we will subtract 45 degrees from this equation, equation number 1, and we will get that alpha plus 3x equals to 180 degrees minus 45 degrees equals to 135 degrees. So we found out that angle, that alpha, according to equation number 1, alpha plus 3x equals to 135 degrees. Likewise, in triangle PSR, the sum of the angles must be equal also to 180 degrees. That is to say, beta, this triangle PSR, that is to say beta plus 135 degrees plus angle x must be equal to 180 degrees. I repeat again, in triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, beta plus 135 degrees plus x must be equal to 180 degrees. We will subtract 135 degrees from this equation, equation number 2, and we will get that beta plus x equals to 180 degrees minus 135 degrees is 45 degrees. So here we will multiply equation number 2 by 3, and we will get that 3 beta plus 3x equals to 45 degrees times 3 is 135 degrees. So according to equation number 1, alpha plus 3x equals to 135 degrees, and according to equation number 2, 3 beta plus 3x equals to 135 degrees. So this side of equation number 1 equals to this side of equation number 2, because both sides are equal to 135 degrees. So we can create equation number 3 that states that the left side of equation number 1 equals to the left side of equation number 2. So according to equation number 3, alpha plus 3x equals to 3 beta plus 3x. Here we will subtract 3x from this equation, equation number 3. 4x will get cancelled, and we got, according to equation number 3, that alpha equals to 3 beta. Again, according to equation number 3, alpha equals to 3 beta. Okay, in the next step, we will do a construction in our drawing from point Q. We will draw a straight line to PR in such a way that the angle that created here will be equal to x. Okay, so here we draw a straight line in such a way that this angle equals to x, but we know that angle PQR equals to 3x. Angle PQR equals to 3x, and this angle equals to x, so the rest must be equal to 2x. So this angle PQ must be equal to 2x in order to complete the sum of those two angles to 3x, as angle PQR equals to 3x. Okay? Then we will define the touching point between the straight line from point Q to PR as point M. Actually, triangle QMR is an isosceles triangle because of the fact that those two angles, they are equal to each other, they are both equal to x. And the base of the isosceles triangle, triangle QMR, is QR. And actually, MS, if we join point M and S together by a straight line, then MS is the median to the isosceles triangle, triangle QMR, or it is the median to the base of the isosceles triangle, triangle QMR. Why MS is the median to the base? Because line segment MS bisects the base QR into two equal parts. That is to say, QS equals to SR. It is given as the question that QS equals to SR. So MS is the median to the base of the associated triangle, triangle QMR, but we have rule number 3. According to rule number 3, the median to the base of an isosceles triangle, it is perpendicular to the base. So MS, the median MS, is perpendicular to the base QR. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay? Those angles are right angles. And In the next step, I will present to you a new rule number 4. According to rule number 4, an exterior angle of a triangle is equal to the sum of the two angles that are not adjacent to it. I will read rule number 4 again. According to rule number 4, an exterior angle of a triangle is equal to the sum of the two angles that are not adjacent to it. So, what is the meaning of rule number 4? The meaning of rule number 4 is that if we have triangle ABC, any triangle has three interior angles. So triangle ABC has three interior angles. Actually, any triangle has three interior angles and also three exterior angles. So alpha, beta, and gamma are defined as the interior angles of triangle ABC. And angle SAB, this angle, is defined as an exterior angle of triangle ABC. And according to rule number 4, an exterior angle of a triangle, that is to say angle SAB, is equal to the sum of the two angles that are not adjacent to it. Okay, so the exterior angle SAB, this angle, is equal to the sum of the two angles that are not adjacent to it. Angle gamma is adjacent to angle SAB. So the other two angles that are not adjacent to angle SAB are alpha and beta. And according to rule number 4, it equals to the sum of the two angles that are not adjacent to it. So the two angles is alpha and beta, and the sum of the two angles is alpha plus beta. So angle SAB equals to alpha plus beta according to rule number 4. Okay? And we can implement rule number 4 in our drawing. Because we have the triangle QMR is an isosceles triangle. Triangle QMR has three interior angles. This angle is interior angle, this angle is interior angle, and this angle, it is also interior angle. Angle PMQ is an exterior angle. This angle PMQ is an exterior angle. And according to rule number 4, the exterior angle PMQ of triangle QMR is equal to the sum of the two angles that are not adjacent to it. And the two angles that are not adjacent to it are those two angles, because this angle is adjacent to angle PMQ. Those are the two angles that are not adjacent to it, and the sum of those two angles is x plus x, that is to say 2x. So we found out that angle PMQ is 2x, is equal to 2x. Therefore, triangle PMQ is an isosceles triangle because it has two angles that are equal to each other. And according to the rule that in front of equal angles in the triangles there are equal sides, we will get that in front of those two angles we have sides PQ and PM, and according to the rule they are equal to each other. That is to say PQ equals to PM. We found out that PQ equals to PM. Okay? In the next step, from point P, we will draw perpendicular to QM and then extend it until it touches QS. So, first of all, we will draw perpendicular to QM and then we will extend it until it touches QS at point M, point N. Point M is the touching point between QS and the perpendicular from P. And we will define the touching point between the perpendicular from P to QM as L, point L. So this is perpendicular to QM. It means that this angle equals to 90 degrees and this angle also equal to 90 degrees. Okay, so we will focus on triangle PQL and PLM. On triangle PQL and PLM, triangle PQL, this triangle, this is a right triangle, and triangle PLM, that is also a right triangle, this triangle. On those two triangles, we know that those two angles are equal to each other, they are both equal to 2x. So we can write down that angle PQL is equal to angle PML, and both angles are equal to 2x. Okay, I repeat again. Angle PQL of triangle PQL equals to angle PML of triangle PML, and they are both equal to 2x. We just right now drew perpendicular to QM, so those two angles, they are also equal to each other, they are both equal to 90 degrees. So angle PLQ is equal to angle PLM, and both angles are right angles, that is to say they are equal to 90 degrees. I'll repeat again. Angle PLQ equals to angle PLM, and they are both right angles, that is to say they are equal to 90 degrees. And those two angles, they are equal to each other according to third angle theorem. So I write it down. Angle QPL is equal to angle angle PQ, angle QPL is equal to angle MPL, this angle that I signed, marked in the red line, angle MPL, and those two angles are equal to each other according to third angle theorem. I'll repeat again. Angle QPL equals to angle MPL according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And what is the reason? Because of the fact that it's complementary to 180 degrees. Okay, so here we have those two angles in triangle PLQ congruent to those two angles in triangle PLM. So in those two triangles we have two pairs of angles that's congruent. Therefore the third pair of angles, that is to say those two angles, must also congruent because they are complementary to 180 degrees. Okay, the sum of the angles in any triangle is 180 degrees, and if we have two angles that are equal, then the third angle equals to 180 degrees minus the sum of the two other angles, and the sum of the two other angles are equal in both triangles. Therefore, the third pair of angles must also equal to each other. And if we define angle QPL as theta, then angle LPM will be also equal to theta because they are equal to each other. Okay, now this angle also equals to theta. As you can see from the drawing, it is very easy to see from the drawing that theta plus theta equals to alpha plus beta. Actually, alpha plus beta is angle QPR, and angle QPR, it is also theta plus theta. So we can write down that theta plus theta equals to alpha plus beta. Theta plus theta is 2 theta, and it equals to alpha plus beta. But according to equation number 3, we have already found out that alpha equals to 3 beta. So we can substitute alpha in this equation by 3 beta, and we will get that 2 theta equals to alpha is 3 beta plus beta. 3 beta plus beta is 4 beta. We'll divide this equation by 2 and we will get that theta equals to 2 beta. Theta equals to 2 beta. So we can write here that theta equals to 2 beta. And here also theta equals to 2 beta. And so this angle equals to 2 beta, and this angle equals to beta. So this angle MPS, must be equal to beta, because beta plus beta equals to 2 beta. So this angle equals to beta. Angle NPS equals to beta. again, theta minus beta equals to beta, because theta is 2 beta and 2 beta minus beta equals to beta. Okay? And here we have angle MSN equals to 90 degrees. This is a right angle, but this angle equals to 45 degrees. What is the value of this angle? It equals to 90 degrees minus 45 degrees. Okay, this angle equals to 90 degrees minus 45 degrees. That is to say, it equals to 45 degrees. So we actually found out that angle MSP equals to 45 degrees. In the next step, we will prove that those two triangles can go into each other. So I will copy this triangle in a new page, and we will prove that they can go into each other. Okay, so triangle PNS, triangle PNS. Is can go to triangle PMS, this triangle. I repeat again, we will prove the triangle PMS, the green triangle, is congruent to the white triangle, triangle PSM. I write it down. We'll prove that the green triangle, triangle PNS, is congruent to the white triangle, triangle PMS. Why they congruent to each other? First of all, those two angles, they are equal to each other, they are both equal to beta. So angle NPS of the green triangle equals to angle MPS of the white triangle, and they are both equal to beta. Okay? We also have a common side. PS is a common side. It belongs to both triangles, so we can write down that PS equals to PS as a common side that belongs to both triangles. Those two angles, they are also equal to each other. They are both equal to 45 degrees. So angle NSP in the green triangle equals to angle PSM in the white triangle, and they are both equal to 45 degrees. So we actually proved that the green triangle, triangle PNS, congruent, this is the sign of congruent, to the white triangle, triangle PSM. And they can go into each other according to angle side, angle rule. I repeat again, we actually proved that the green triangle, triangle PNS, can point to the white triangle, triangle PSM, according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if two angles and the side that included between those two angles in one triangle can point to two angles and the side that included in another triangle, then those two triangles can point to each other according to angle side angle rule. And here we actually found that those two angles in the green triangle and the side that included between them, that is to say PS, can point to those two angles and the side that included between them, PS, in the white triangle. Therefore we prove that those two triangles can point to each other according to angle side angle rule. And from the fact that the two triangles can point to each other, we will conclude that NS equals to MS. NS equals to MS. So I'll write it here also. NS equals to MS. We will join together points N and M by straight line. I will draw triangle NSM again. M, N, S, this is a right angle, and we know that NS equals to MS, NS equals to MS. We know that the sum of the angles in any triangle is equal to 180 degrees. This is a right angle, it equals to 90 degrees. So the sum of those two angles must be equal to 90 degrees. And in front of equal sides in the triangle, there are equal angles. In front of those two equal sides, NS and NM, there are equal angles. That is to say, those two angles are equal to each other, and we know that the sum of those two angles are also equal to 90 degrees. So if we define one angle as y, then the other angle will be also equal to y. That is to say, y plus y must be equal to 90 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. We got that 2y equals to 90 degrees. We will divide this equation by 2, and we will get that y equals to 90 degrees over 2 is 45 degrees. So we found out that this angle equals to 45 degrees, and this angle also equals to 45 degrees. So we can write down angle S and M equals to 45 degrees. First of all, we join together points M and M by a straight line. And we found out that angle S and M equals to 45 degrees. Angle S and M equals to 45 degrees. Okay. Here also we know that MS equals to NS. MS equals to NS. In the next step, we will focus on triangle PNS and on triangle PMN, and we will prove that those two triangles can go into each other. So I will draw them again in order to clarify the picture. We will prove the triangle PQN is congruent to triangle PMN. I will repeat again. We will prove that the green triangle PQN is congruent to the white triangle PNM. The green triangle PQN is congruent to the white triangle PNM. Why they can go into each other? First of all, we have already found out that PQ equals to PM. PQ equals to PM. Those two angles, they are equal to each other. That is to say, they are both equal to 2 beta. That is to say, angle QPN in the green triangle is equal to angle NPM in the white triangle, and both angles they are equal to 2 beta, and we have a common side. PN is a common side, it belongs to both triangles, so PN equals to PN is a common side that belongs to both triangles. Okay, so we actually proved that the green triangle PQN, the green triangle, congruent to the white triangle PNM, according to side angle side rule. I will repeat again. We actually proved that the green triangle PQN can go into the white triangle PNM according to side angle side rule. So what is side angle side rule? Side angle side rule is that if you prove that the two sides and the angle between them in one triangle congruent to 2 sides and the angle between them in another triangle, then you proved that those 2 triangles can go into each other according to side angle side rule. And we actually proved that those 2 sides and the angle between them, that is to say this angle, in the green triangle can go into those 2 sides and the angle between them, that is to say 2 beta, in the white triangle. Therefore we proved that those 2 right angles can go into each other according to side angle side rule. And from the fact that those 2 triangles can go into each other, we will conclude that QN equals to NM. QN equals to NM. QN equals to NM. So I will join according to the rule that corresponding sides in congruent triangles are equal to each other. Those 2 triangles can go into each other, therefore the corresponding sides QN and NM will be also equal to each other. So I will draw, we'll join points Q and M together by a straight line, and I will draw triangle Q and M again. I will draw this triangle Q and M again. We know that Qn equals to Nm. Angle MQN equals to X. So I draw triangle Q and M again. In triangle Q and M, we have two equal sides. That is to say, Qn equals to Nm. We just right now proved that Qn equals to Nm. And we have the rule that according in front of equal sides in the triangle, there are equal angles. According in front of these sides that are equal to each other, there are equal angles. So we have those two angles that are located in front of those two sides, and according to the rule that I stated, the sides, the angles are also equal to each other, because in front of equal sides there are equal angles. But this angle equals to X, so this angle must be also equal to X, and this is actually MNS. And in triangle QMN, we have three angles. Angle MNS is an exterior angle of triangle MNS. This is an exterior angle of triangle QMN. And according to rule number 4, the exterior angle of any triangle is equal to the sum of the angles that are not adjacent to it. The only two angles that are not adjacent to it are x plus x and x and x, x and x, because this angle is adjacent to it. So the sum of the two angles that are not adjacent to it are x plus x, that is to say it equals to 2x. So we found out that this angle, the exterior angle MNS, equals to 2x. Angle MNS equals to 2x. But we have already found out that this angle MNS, this angle is equal to 45 degrees. So from one side, angle MNS equals to 2x, and from the other side it equals to 45 degrees. From this equation, we will derive that 2x equals to 45 degrees. We will divide this equation by 2, and we will get that x equals to 45 degrees over 2, that is to say angle x equals to 22.5 degrees. So we found out that angle x equals to 22.5 degrees. We finished with the second method, so in the next step I will summarize the lecture. We found the value of angle x in two different methods. In the first method, here we have triangle PQN. We know that QS equals to SR, angle PSQ equals to 45 degrees, angle PQR equals to 3x, angle PRQ equals to x, and we want to find out the value of angle x. So we defined this angle as alpha, this angle as beta. This angle, we can define it as y or x, it doesn't matter, but it is not the same x, it is other. And we know that the sum of the angles on one side of the straight line is equal to 180 degrees. So if we focus on the upper side of the straight line QR, then the sum of its angles must be equal, at point S, the sum of the angles must be equal to 180 degrees. So here, 45 degrees plus angle X or Y, whatever, must be equal to 180 degrees. So here, 45 degrees plus angle Y must be equal to 180 degrees, according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. We subtract the 45 degrees from this equation and we get that angle Y equals to 135 degrees. So this angle equals to 135 degrees. Okay? And then I presented to you a new rule, the law of sines. The law of sines is true in any triangle. You can use it in any triangle. If we have this triangle and we know that the length of this angle is A units, the length of this angle is B units, and the length of this angle is C units, then according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. Okay, from this formula, we will derive that A over sine A equals to B over sine B. We will multiply this formula by sine A and then we will divide it by B, and we will get that A over B equals to sine A over sine B. So what is the meaning of this formula? The meaning of this formula is that the ratio between the sides lengths in any triangle is equal to the ratio between the opposite angles. Okay? The ratio between the side lengths in any triangle equals to the ratio between the opposite angles. Okay? This is the rule that we derived from the law of sines. Then in our original drawing, we can create the equation that PS over QS equals to PS over SR. PS over QS equals to PS over SR. Why they are equal to each other? Because QS equals to SR. It is given as the equation that QS equals to SR. But according to the rule that I mentioned that we derived from the law of sines, we know that the ratio between the sides lengths of any triangle equals to the ratio between the opposite angles. So if we focus on triangle PQS, then PS over QS, according to the rule that I mentioned, will be equal to sine 3x over sine alpha. PS over QS equals to sine 3x over sine alpha. And in triangle PSR, PS over SR, PS over SR will be equal to sine x over sine beta. Sine x over sine beta. We know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle PQS, the sum of its angles is 180 degrees. That is to say, alpha plus 3x plus 45 degrees equals to 180 degrees. We subtracted 3x and also 45 degrees from this equation number 2, and we got that alpha equals to 180 degrees minus 3x plus 45 degrees. Then we focused on triangle PSR. Triangle PSR, the sum of the angles also equals to 180 degrees. That is to say, beta plus x plus 135 degrees equals to 180 degrees. We subtracted x and also 135 degrees from this equation, equation number 3, and we got that beta equals to 45 degrees minus x, because 180 degrees minus 135 degrees is 45 degrees. So in conclusion, we got that beta equals to 45 degrees minus x. Then we substituted alpha and beta in equation number 1 by the values that we found for alpha and beta in equation number 2 and equation number 3. And we got that sine 3x over sine alpha. Alpha equals to 180 degrees minus 3x plus 45 degrees, according to equation number 2. And it equals to sine x over sine beta, and according to equation number 3, beta equals to 45 degrees minus x. And we have the trigonometric identity that sine 180 degrees minus theta equals to sine theta. So actually here, sine 180 degrees minus 3x plus 45 degrees, according to this trigonometric identity, will be equal to sine 3x plus 45 degrees. So we got that sine 3x over sine 3x plus 45 degrees equals to sine x over sine 45 degrees minus x. Then we cross multiplied this equation, equation number 1, and we got this expression. Then we multiplied this equation, equation number 1 by 2. We got this expression. So the function 2x times 2 sine 3x times sine 45 degrees minus x, it is actually similar to the trigonometric identity that 2 sine A sine B equals to cosine A minus B minus cosine A plus B. So we can use this trigonometric identity in order to simplify this expression. In this expression, A equals to 3x and B equals to 45 degrees minus x. So according to this trigonometric identity, 2 sine 3x sine 45 degrees minus x equals to cosine A minus B. Here cosine A minus B is A is 3x and B is 45 degrees minus x. So A minus B is 3x minus x, that is to say it is 4x, and 0 minus 45 degrees is minus 45 degrees. So in conclusion, we got that cosine 4x minus 45 degrees, this expression equals to cosine 4x minus 45 degrees, and we also must subtract cosine A plus B, and here cosine A plus B, A is 3x and B is 45 degrees minus x. So 3x plus minus x is 3x minus x, and 3x minus x is 2x. And here 0 plus 45 degrees is 45 degrees. So in conclusion, we got here cosine 2x plus 45 degrees. So we finished with this expression. Then we went to the other side of the expression, 2 sine x sine 3x plus 45 degrees. Here A equals to x and B equals to 3x plus 45 degrees. So 2 sine A sine B equals to cosine A minus B. In our specific expression, cosine A minus B means cosine A is x and B is 3x minus 45 degrees. So x minus 3x is minus 2x. And 0 minus 45 degrees is minus 45 degrees. So we got here that the expression is cosine of minus 2x plus 45 degrees. And we have also to subtract cosine A plus B. Here cosine A plus B, A is x and B is 3x plus 45 degrees. So x plus 3x is 4x and 0 plus 45 degrees is 45 degrees. So in conclusion, we got here cosine 4x plus 45 degrees. But here we got cosine minus 2x plus 45 degrees, but according to the trigonometric identity that cosine minus x equals to cosine x, which we can change the negative sign here to positive sign. So in conclusion we got here cosine 2x plus 45 degrees. Okay, so here what we have in equation number 1, we have cosine 4x minus 45 degrees, so I copied it here, and then I added to this equation cosine 4x plus 45 degrees, and here we have minus cosine 2x plus 45 degrees, so I added to this equation cosine 2x plus 45 degrees, and actually cosine 2x plus 45 degrees plus cosine 2x plus 45 degrees equals to 2 cosine 2x plus 45 degrees. So in conclusion we got this equation, and here this expression cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees is similar to the trigonometric identity that says that cosine c plus cosine d equals to 2 cosine c plus d over 2 times cosine c minus d over 2. And in our specific expression, c equals to 4x minus 45 degrees and d equals to 4x plus 45 degrees. So according to this trigonometric identity, cosine c plus cosine d equals to 2 cosine c plus d over 2. In our specific expression, 2 cosine c plus d over 2 means 2 cosine c plus d. C plus d is 4x plus 4x is 8x, and 8x over 2 is 4x. And minus 45 degrees plus 45 degrees is 0, so in conclusion we got 2 cosine 4x, and it also equals to, it is 2 cosine c plus d over 2 times cosine c minus d over 2. So cosine c minus d over 2 means that c minus d, here 4x minus 4x is 0, and minus 45 degrees is minus 90 degrees, and minus 90 degrees over 2 is minus 45 degrees. So we got here cosine minus 45 degrees, but because of the fact that cosine minus x equals to cosine x, we can change the sign of minus to plus, so we got here cosine 45 degrees. And we have also the second expression. The second expression is 2 cosine 2x plus 45 degrees. That is similar to the trigonometric identity that cosine a plus b equals to cosine a cosine b minus sine a sine b. So in our specific expression, we know that a is 2x because it is 2 times cosine 2x plus 45 degrees. It means that a equals to 2x and b equals to 45 degrees. So actually cosine a cosine b, it is actually cosine 2x times cosine 45 degrees minus 2 sine a, that is 2x, sine 45 degrees, that is b. And we multiply it by 2 because in the original expression we have here 2. So we multiply it by 2 because we have 2 in the original expression. Okay, so here we got this expression. We divided this expression by 2 times cosine 45 degrees. We know that sine 45 degrees is equal to cosine 45 degrees. So we divided this equation number 1, by 2 cosine 45 degrees. This 2 is cancelled, cosine 45 degrees is cancelled. Here 2 is cancelled, cosine 45 degrees is cancelled. And here also 2 is cancelled, and sine 45 degrees is cancelled because sine 45 degrees equals to cosine 45 degrees. So what is left of equation number 1 after we cancelled 2 cosine 45 degrees? What is left in this side is left only cosine 4x, and on the other side is left cosine 2x minus sine 2x. Here we added to this equation number 1 sine 2x, and we subtracted cosine 4x. So in conclusion, we got that sine 2x equals to cosine 2x minus cosine 4x. And we know that sine 2x equals to 2 sine x. Cosine x, it is a trigonometric identity. And cosine 2x minus cosine 4x, we have, it is very similar to the trigonometric identity that states that cosine c minus cosine d equals to 2 sine d plus c over 2 times sine d minus c over 2. So in our specific quadratic, equation, c, here we have c equals to 2x. So you can see here, c equals to 2x and d equals to 4x. So cosine c minus cosine d equals to 2 sine d plus c over 2. It equals to 2 sine d plus c over 2. D plus c. D is 4x, c is 2x, so 4x plus 2x is 6x, and 6 over x over 2 is 3x. So it is actually 2 sine 3x times sine d minus c over 2. D is 4x, c is 2x, and 4x minus 2x is 2x, and 2x over 2 is x. So we got here, in this side of the equation, 2 sine 3x times sine x. And it equals to 2 sine x cosine x. We divided this equation number 1, by 2 sine x, and we got that cosine x equals to sine 3x. We have the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha. According to this trigonometric identity, cosine x equals to sine 90 degrees minus x, and sine 90 degrees minus x, according to equation number 1, equals to sine 3x. So sine 90 degrees minus x equals to sine x, means that 90 degrees minus x equals to 3x. We added x to this equation number 1, and we got that x, 90 degrees equals to 4x. Then we divided this equation number 1 by 4, and we got that x equals to 90 degrees over 4. 90 degrees over 4 is 25 degrees, 0.4, 22 degrees, 0.5. So we got that the value of angle x is 22.5 degrees. This is according to the first method. Then I explain to you how to find out the value of x according to the second method. In the second method, we defined this angle is alpha, this angle is beta, and we already found out that this angle equals to 135 degrees. And we know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle PQS, the sum of its angles is equal to 180 degrees. That is to say, alpha plus 3s plus 45 degrees equals to 180 degrees. Here we subtracted 45 degrees from this equation number 1, and we got that alpha plus 3x equals to 135 degrees. Then in triangle PSR, the sum of the angles in triangle PSR equals to 180 degrees. That is to say, beta plus 135 degrees plus x equals to 180 degrees. We subtracted 135 degrees from this equation number 2, and we got that beta plus x equals to 45 degrees. We multiplied this equation number 2 by 3, and we got that 3 beta plus 3x equals to 135 degrees. So we can write down equation number 3 that states that this side of equation number 1 that equals to 135 degrees equals to this side of equation number 2 that it also equals to 135 degrees. That is to say, alpha plus 3x equals to 3 beta plus 3x. We subtracted 3x from this equation number 3, and we got that alpha equals to 3 beta. Okay, alpha equals to 3 beta. Then we did a construction. From point Q, we drew a straight line to PR. in such a way that this angle will be equal to x. So because of the fact that this angle equals to x, then triangle QMR is an isosceles triangle because it has two angles that are equal to each other, they are both equal to x, and the base of the isosceles triangle, triangle QMR, is QR. We join points M and S together by a straight line. MS is the median to the base in the isosceles triangle, triangle QMR, and according to rule number 3, the median to the base it is not only bisects the base, but it is also perpendicular to the base. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? And then I presented to you rule number 4. According to rule number 4, an external angle of a triangle is equal to the sum of the two angles that are not adjacent to it. So what is the meaning of rule number 4? The meaning of rule number 4 is that if we have triangle ABC, angles alpha, beta, and gamma are the interior angles of triangle ABC, and angle SAB is the exterior angle of triangle ABC. And according to rule number 4, the exterior angle SAB of triangle ABC is equal to the sum of the two angles that are not adjacent to it. That is to say, this angle gamma is adjacent to angle SAB, and the only two angles that are not adjacent to angle SAB are those two angles. And according to rule number 4, it equals to the sum of the two angles that are not adjacent to it. That is to say, angle SAB equals to alpha plus beta, that is two angles that are not adjacent to angle SAB. So, according to rule number 4, the external angle SAB equals to alpha plus beta. And we can implement rule number 4 in our drawing, because in our drawing we have triangle QMR, and the external angle PMQ of triangle QMR will be equal to the sum of the two angles that are not adjacent to it. That is to say, it will be equal to x plus x. That is to say, angle PMQ equals to 2x. Okay, so this triangle is an isosceles triangle because it has two angles that are equal to each other, and we have the rule that in front of equal angles there are equal sides. That is to say, PM equals to PQ, PQ equals to PM. And then we drew perpendicular from point P to QM, that is to say, this angle equals to 90 degrees and this angle equals to 90 degrees, and then we extended the perpendicular until it touches QS at point N. Then we proved actually that those two triangles are similar to each other. Why? Because first of all, so we focus on triangle PQL and triangle PLM. Angle PQL equals to angle PML equals to 2x. Those two angles are equal to each other, they are both equal to 2x. Those two angles are also equal to each other, they are both equal to 90 degrees. Angle QQL, angle PLQ equals to angle PLM equals to 90 degrees. And those two angles, the angle in the red color and the angle here, they are equal to each other according to Fern's theorem. Angle QQL equals to angle MPL according to Fern's theorem. So what is Fern's theorem? Fern's theorem states that if two angles in one triangle congruent to two angles in another triangle, then the first pair of angles must also congruent. Why? Because it is complementary to 180 degrees. We found that those two angles in triangle PQL congruent to those two angles in triangle PLM. Therefore, we have two pairs of angles that are congruent in those two triangles. Therefore, the third pair of angles must also congruent because it is complementary to 180 degrees. Okay, so those two angles, they are equal to each other, and if one angle is theta, then the other angle must be also equal to theta because of the fact that they are equal to each other. So this angle equals to theta, and this angle also equals to theta. You can see from the drawing that theta plus theta equals to alpha plus beta. Alpha plus theta equals to alpha plus beta. That is to say 2 theta equals to alpha plus beta. But we have already found out that alpha equals to 3 beta. So we can substitute alpha in this equation by 3 beta. We did it and we got that 2 theta equals to alpha is 3 beta plus beta. So 2 theta equals to 3 beta plus beta is 4 beta. 2 theta equals to 4 beta. We divided this equation by 2 and we got that theta equals to 2 beta. Theta equals to 2 beta. So we can write here that theta equals to 2 beta and then also theta equals to 2 beta. But here, this angle that I marked in the red color equals to 2 beta. And this angle equals to beta. So if we subtract the angle in the red color from beta, we will get the missing angle that is here. The angle in the red color is 2 beta, this angle is beta, so 2 beta minus beta equals to beta. That is to say this angle NPS equals to beta. And here we have this angle is a right angle. But this angle equals to 45 degrees. So what is the value of this angle? It must be equal to 90 degrees minus 45 degrees because this is the missing angle. So this angle equals to 45 degrees. Then we proved that those two triangles can go into each other. So I copied again these two triangles and we proved that they can go into each other. We proved the green triangle P and S is congruent to the white triangle PMS. First of all, we know that those two angles are equal to each other. That is to say, angle NPS equals to angle NPS, and they are both equal to beta. We have PS is a common side, it belongs to both triangles. So PS equals to PS is a common side. And those two angles, they are both equal to about 45 degrees. Angle SP equals to angle PSM, and they are both equal to 45 degrees. So we actually proved that the green triangle P and S can go into the white triangle PSM according to angle side angle rule. What is angle side angle rule? Angle side angle rule is that if you prove that the two angles and the side between those two angles, one triangle can go to two angles and the side that's included between those two angles. In another triangle, then we proved that the triangles can go into each other according to angle side angle rule. And we proved that those two angles and the side between them, that is to say PS in the white triangle, can go into those two angles and the side between them, that is to say PS in the green triangle. Therefore, we proved that those two triangles can go into each other according to angle side angle rule. From that fact, we concluded that NS equals to MS. NS equals to SM according to the rule that corresponding angles in congruent triangles are equal to each other. Those two angles can go into each other. Those two triangles can go into each other. Therefore, the corresponding sides, that is to say SN and MS, must be equal to each other. So NS equals to SM and S equals to SM. So I drew this triangle MSN to alone, and we know that this is triangle MSN. We know that MS equals to NS. Those two angles, and this is a right angle. And we know that in front of equal sides in the triangle there are equal angles. That is to say, SN equals to SM, therefore those two angles must be equal to each other. So if this angle is Y, then this angle also equals to Y. So the sum of those two angles are Y plus Y, and Y plus Y must be equal to 90 degrees, according to the rule that the sum of the angles in any triangle is equals to 180 degrees. So we got that 2Y equals to 90 degrees. we divided this equation by 2 and we got that angle y equals to 45 degrees. So this angle equals to 45 degrees and this angle also equals to 45 degrees. Okay, so here angle MNS equals to 45 degrees. Angle MNS equals to 45 degrees. Okay. Then we proved that triangle PQN, the green triangle, can point to the white triangle, triangle PMN. Why they can point to each other? First of all, PQ equals to PM. Here, PQ equals to PM. And those two angles are equal to each other, they are both equal to beta. Angle NPQ equals to angle NPM, and they are both equal to beta. So they are equal to each other, and PN is a common side, it belongs to both triangles, so PN equals to PN. It's a common side that belongs to both triangles, so we prove that those two triangles can point to each other according to angle side angle rule. And from that fact, we conclude that QN equals to MN. QN equals to MN, so I draw triangle MQN alone, and here you can see we found that MN equals to QN, and we know that this angle equals to X, and according to the rule that in front of equal sides in the triangle there are equal angles, it means that those two sides are equal to each other, therefore those two angles must be also equal to each other, and this angle equals to X, so this angle must be also equal to X. So those two angles are equal to 2X, and the exterior angle of triangle QMN, according to rule number 4, it equals to the sum of the two angles that are not adjacent to it. That is to say, it equals to X plus X. So angle MNS equals to 2X according to rule number 4. But we have already found out that angle MNS equals to 45 degrees. So from one side, angle MNS equals to 2X according to rule number 4, and from the other side, angle MNS equals to 45 degrees. From this equation, we will derive that 2x equals to 45 degrees. We will divide this equation by 2 and we will get that x equals to 45 degrees over 2 is 22.5 degrees. So we found out that angle x, the angle that we are looking for, equals to 22.5 degrees. Okay, so in both methods, we found out that the value of angle x is 22.5 degrees. Okay, thank you very much.